in solving letter A, we need to know what are the given. So in letter A, we have the following. We have the time from 1 to 2, it is 2 seconds. And then we have the acceleration due to gravity. But take note that the acceleration due to gravity, as you move from 1 to 2, by the way, I would like to make it a point that this is from 1.1 to 2. Okay, and from point 1 to 2, the acceleration due to gravity, it is actually decelerating. If it is decelerating, meaning it's slowing down until eventually the body stops moving, it means that we have a negative acceleration or a deceleration. Now from there, the other thing that we know is that the velocity at point 2 is actually 0 because it stopped moving. There you go, the body was able to reach the maximum height. Now, we are being asked, what is the initial velocity? If we look at the equations of motion, or the SOVAT that we have, among the equations here, what we have is the acceleration, we have the final velocity, we have the time, and we're looking for the initial velocity. And equation number 2, which defines acceleration, would be proper to make use of, because you have the acceleration, you have the time, you have the final velocity, but you don't have the initial velocity. So rewriting the definition of acceleration, acceleration is equal to, you have the final velocity minus the initial velocity divided by time. And finding for the initial velocity, this will be a times t is equal to final velocity minus initial velocity. Initial velocity will therefore be equal to final velocity minus acceleration times time. And if we're going to equate it with what we have, the initial velocity, which is u1, this is now u1, is equal to the final velocity, which is your v2, minus the acceleration here is the acceleration due to gravity, which is actually negative, so negative 9.81, times the time will be time 1 to 2. Substituting, u1 will be equal to 0, minus and minus, you have positive 9.81 times you have 2 seconds as time from 1 to 2. Then you have here the initial velocity, which is equal to 19.6 meters per second.